Hey, welcome to Premier Hill. Yeah, dare you to subscribe if this helps you out, and stuff. So, Leveldb. This is a thing that I could not find any information on. This is how Minecraft stores this save data, everything you're trying to access. So, I'm going to explain to you basically how it works, and if you're programming, this will be very helpful, and this will satisfy all your curiosity. Stay tuned because I know a lot more ways you can do stuff and editors and ways to access this and ways to test your code. So here's get into this. Okay, so Leveldb. This is a fork of Google, and it has added zlib compression, which also supports other operating systems if it's compiled into it. But yes, it is a very, very simple and efficient algorithm. So now the thing is different between most of the databases like Java is it's in Little Indian, and a lot of people don't understand Little Indian to Big Indian. But I got to give you a little brief overview. This is the difference. I mean, it literally takes the bytes. These are bytes. This is hexadecimal. This is bits. It's just this is the Big Indian format, and this is the Little Indian format. Just for reference, so you understand it. It's not bits. It's the actual bytes, but I'm showing bit representation so you can see it doesn't change the bits. It just changes the byte location. Okay, so I think you can understand that. Let's move on. So this is where I got a lot of this information here when it comes to like the actual structure of the database. Once you get to load the database up, you're going to have a whole bunch of keys to access. You're not going to know what the hell because it's all in bytes. It's all, this whole system is a byte database. So all the keys and all the data are stored in bytes. Don't forget that. All right, so we got the chunk key, and that is two 32-bit for, this is for the overworld, and you have 8 bytes for the overworld. And then it just adds a whole nother 32, did I say byte? I meant bit, you know, and it's a signed integer, so it has negative and positive, and you know, the only difference is when it goes negative, it uses 1 bit left, 1 bit less, and it flags it when it's negative by the final bit being a 1 or a 0. So you get, it splits it in two, negative and positive. That's the difference between signed and unsigned. If you didn't know, now you know. Now, those are the values, and it's literally going to look, the end value for Bedrock would be in little, and so the end value to access the end would be this, and then it would be 2 if it was the nether. So there you go. And that's what it'll look like in hex and, obviously in decimal. So let's go further on now. Data 3D, this is where your height map is stored, and so you access it with this hexadecimal value, or if you can translate, you can convert ASCII into hex or ASCII into decimal. This is what you would need to know to access the data 3D, because you need to access it within bytes. So you need to convert these into actual bytes in whatever language you're using to access this layer or any other layer, so I don't have to repeat myself. All right, so biomes are pretty much, they changed it. So now you can literally access. Now I know biomes. This is literally not 25. It says this, but yeah, I've corrected them. I'm pretty confident now that it's 24. Anyways, so the height map is literally this. It is a short. There's 256, 16 times 16 xz, the blocks, a chunk. It's the top part. It's from bottom to top, and it's reversed. I mean, I didn't even put that in here, but it is literally reversed. It's Z to X order. So you don't forget that, because it's backwards. It's backwards to all the other chunk things, like data 2D, and I didn't put that up here. I should have, because it's both. They're both backwards. The old format, like 1.17. This is 1 point, the end of 1.17, 1.18. So, and then you got the chunk version. This will tell you what version you're on. It gives you a byte value that actually gives you the version. And I don't know the actual version at the top of my head, but you can certainly check them and find out for yourself. I know X16 is 1.17, and I can't remember what 1.18 or 19 are. But anyways, the chunk version doesn't change after 1.18.30 so far. I haven't noticed a difference, but I know there's a lot of differences between the version because it went up a lot of hexadecimal values. So let's move forward. So you pretty much should be able to understand this. It's ZYX order. It's 2 bytes. You just have to calculate them. And if you need a representation, I wonder if I got one in my thing. I don't. Can't find out. I can bring it up. I don't think. Anyways, leave a comment below if you need more information on that. But it's pretty much, it's ZX order means that it goes from Z. You know, Z is south, or negative Z, positive Z. I always get confused. I'm sure you do too. If you don't, then damn, you got a good memory. All right. So data, I don't know because I have not used this yet. This is ancient, but it's ancient version 1.0. Anyways, so this is where we get to the most complicated thing of where you want to access all your blocks. And so I've got this written out so you understand how the actual, because this is really ambiguous, hard to figure out, hard to understand. The hardest part of Leveldb is this, is accessing all the blocks inside of a chunk and putting the data back. And so I'm going to explain to you really as fast as I can, but not too fast that you don't understand. So let's go over this. We got the header. The header is 3 bytes when it is below 1.17 point. I think did I put the level in here? It's like the end of 1.17, beginning of 1.18. They did change the header. I can't remember the exact. I thought I wrote it in here, but I didn't. But I just note that it's the one of the last versions of 1.17. I'm pretty sure they changed the header, and it's a certain version, but they use 4 in this. Yeah, that guy, I did put it. I just got it highlighted, and now it's invisible. Yeah, go figure. I blinded myself. Blinded. All right. Anyway, so you see what I'm saying here? I think probably not. Hopefully, I didn't lose you. So it's not that complicated once you understand it. So listen closely and listen, because I'm going to explain a couple things that you might blow your mind here. So you got the first byte. First byte is the version of the chunk. It only affects the version of the chunk. And it just notifies the how to compact it and everything else that could be done with the chunk. But this is the version of the chunk. It's very important. Now, this is the extra block layer, the second byte of the chunk, which means you're looking at the chunk. You actually access the chunk by typing in the key plus. So you're going to add the key up here very, very cleverly, right? It's going to be bytes, this or this, to get to this point down here. Sorry if I'm making you dizzy, but you got that, and now that right there is the key. And I don't remember, yeah, 2F. You got that key, and then you're going to add in, and I think I got this backwards, and I actually do. It's actually FC, FFD. I'm dyslexic. Wait. It's FF is negative, and then it goes FE. Yeah. So it's FEFEFEDC for negative. Negative. I had that backwards. I'm gonna save this so I don't freaking lose it. Save. Because I had that backwards. I actually had that backwards in my code. I don't know why I thought it was the other way around. So it literally goes, backwards. And this is the new chunk height. So, and now the nether and the end only use that range. You understand, right? So you literally have, wait, let's see here. So you got 16 times, yes. So this would still be 16 because I'm counting 0. 0 is actually 1. And so, anyways, those are the nether. What I highlighted there is the nether. So, but anyways, let me go. I'm backtracking a little bit and going back and forth. So follow along a little bit. I mean, it's kind of hard to stay organized when this is completely not organized. I mean, it is organized. Forgive me. I'm so. This is so frustratingly hard to explain, and I bet you've been frustrated with it. So let's get into this. So let me further explain. Got the version down. Extra block. This means there's only one extra layer, but I guess there's potential for more, but you'll never see more than one extra layer. The game doesn't support it at the moment that I'm aware of. I've tried it and it doesn't want to work. I mean, I don't know if I've actually tried to hard code it in there, but it'd be interesting to try. But I've had it crash trying to put other blocks. Like if you put the wrong block into an extra block, it doesn't like it. Like you can't flip the chest with the grass. Like you can't put grass and then chests with items as the second block. So don't try it. It doesn't work. I've already tried it. It crashes the game. Your game won't even open for some reason. So, anyways, just FYI, save you some time. Don't work. Now, the 4 bytes of this. Now, let me clarify this so we can go back and backtrack because this is going to be something you're going to want to know. And I'm going to have any questions, leave them below if you get confused. If I lose you, if you need I'm going to make a second part of this, just answering specific questions straight to the point of the question. So that's going to be part 2. So comments, if there's no comments below, there ain't going to be a part 2. I ain't going to bother. Why? Nobody wants to see a part 2. Okay, so subchunk, you know what that means. So they added this into these are all subchunks. They actually added it to the header and in the new version, this version, 1.17.30. So that is actually included in the thing. I don't know why they added that, but for maybe some checksum things, but that's there, so you can utilize the key there to double check some things when you're coding it. Anyways, so and then you got the layer. So pretty much, I mean not the layer, but you got the first bit. This is only used for online. So technically, what I've been doing in the wrong term or the long term, and I put it up here when I meant to put it. Well, it doesn't really matter. This is the same thing. We're on compaction level, so I mean, I kind of do have it in the right spot. So we got 8 bits, and it just uses the last 7 bits for compaction, but technically it doesn't because it only uses the first up to 16 values. So you literally get the value of 16. I mean, basically a total value of 16. I mean, if 16 combinations, if they're all ones, the max value is 16. And there's a couple, I think it's 3 and 15 that you want to round, or no, it might be 7. But you want to round because it doesn't use 7 as a key. It uses, and I forgot to look that up, but there is one key that you want to round to the nearest, and I think it's 7 and 15. 7 goes to 8, 15 goes to 16. Or 9 goes to 8, and 15 goes to anything less between a certain values go to it because it doesn't use it. It's got to be a power of 2s. And if it's the power of 3 and 6, 3 and 6 are another value that it has. The padding becomes a thing, but because it still uses the bits as the key, like it still compresses it as maximally as it can. So when it's compaction level, this is where it stores the actual compaction level of how many of the bits it's using. And so it's literally looking at the bit length for the max size of your palette, like with the palette is stored underneath of these little bits of your layer. This is saying how big is the binary bit length. And so this literally, the top layer has the 4 bytes or the 3 bytes, and then it has like a string of literally words, but the computer really looks at it, or the program really looks at it as a string of flags, but it first looks at the compaction level. and the flags or the basically the index is the pointer to the palette below, and it's trying to say, oh well, I only need to represent, 3 blocks, and so 3 blocks can be represented in 2 bits, and so it only needs to put 2 bits, and so that means it can fit 2 blocks in every single 8 bytes, because it uses 8 bytes, so it says, okay, well, I can fit this many. So that means I can fit 16 blocks per word. You do the math. You divide it by 30 to get that words per block. And then then the compaction algorithm that it goes into it just shifts the bits into the one word. And that's where it gets a little confusing. But once you understand that it's the bits that it throws it over into the word, then you with certain numbers you're gonna get a remainder at the end of it. Sometimes you're gonna get 2 extra bytes or 4 extra bytes, and so you're gonna have to make sure you know how to calculate that little remainder by dividing, floor dividing, and then ceiling dividing those numbers, and then you'll get the right accurate thing. And so it goes on, and that's pretty much it. And that's the palette is calculated right after that, and it starts with A. And so if you're looking for the MBT, it's always going to start with the 10, with the basically the value 10. That's not in here, but it'll start right after all that into a MBT tag. MBT, I have to make a whole new video if you really want to understand MBT, named byte tag, or SMBT, which is a stringified name byte tag. If you want to know information about that, leave it in the comments below. I'll make a video on it. I mean, I don't mind. If I get a couple votes on that thing, I might make one. I don't understand it all. It's just hard to explain sometimes. So I think you guys should understand this. There's 496 blocks. That's all there is, and it's all going to be divided. The remaining bits at the end are padding, and I think a lot of places don't really explain that padding too well, because the padding part of it doesn't get it just needs all the words to have all the bits and read all the bits. The leftover padding, you just got to be able to find the pointer to the palette so that you can start the palette to read the blocks, to decode the MBT of the palette. And the palette after this is literally just a palette and a palette and a palette. Well, basically a MBT, MBT, MBT. It's just basically a whole MBT chunk of the block. And I guess I can show you a quick demonstration of what that looks like, really quick, in this in my little test program here. I just got to change a couple things. Sorry for the dang. I should have been prepared for this, because I just thought about it. It needs to be done. So I could just print, because I'm trying to calculate the height, and this is a little bit complicated because I'm trying to do it in all one sweep. So I'm gonna print the actual, instead of the height. I'm just gonna print my block, my actual block, because I'm searching for air, and I'm just gonna take this up here because it doesn't belong there. If I want to make it printed, because it's gonna only print it if it's, well, it's not, oh, either way, it would have printed it if it wasn't air. Anyway, so let's run this, and it's locked. Name blocks is not defined. Oh, there's a world opened. But blocks is not defined. Oh, blocks. Locks. Get out of here. All right. So this is what I'm talking about. After the palette, this is this. And it's going to have the version. This is the MBT after the palette. Now, I can go deeper into it, but this is what it looks like. Dang it. Make the window bigger. So these are all this is how it goes on, and this is the I don't know what I printed out there, so ignore the numbers. I'm not sure what that is yet. I think I was testing the coordinates. But yeah, this is all what it looks like. This is when it's air. And see, I was like, if it's not air, and so it's printing something down here. If it's not air, yeah. See, I'm printing the level and the thing. Anyway, so I'm working on some stuff here with a plugin, but yeah, I got other things coming up here. I got some other things coming, so stay tuned. Okay, here, next thing I got to get into before I lose track of stuff and have to stop the recording. And this is old. This explains pretty much this, and you can go to the website here. I'm going to try. If you guys can't copy this or remember how to paste this, ask me and I'll paste the description. And if you want the link to this, I'll put it there too. So leave me a comment. I'll add the link in there. But I think you should be able to find that. So let me see, where are we at? Legacy train. Okay, block entity. These are the same thing as the block palette, except for it's just the same thing. A list of MPT compounds. Same thing that happens after the end of a chunk. Just gotta sort through them and know how to access. Keep a pointer. Grab the MPT and keep it into an array and keep the track of it. You can write a function that can do the read bytes method, like a buffer or a stream. Works really good. Pending ticks, don't ever use it, but that's where it's located. You know, all this stuff here. Now, there's a bug, and I have a bug report, 44 people so far watching it, and I'm the one that posted the bug report because I was writing an entities program for Amulet, which if you want to check that out, it's on Amulet, well, let me know in the comments. There's a program where I wrote a program where you can move, edit entities around and all sorts of cool things, delete them, and you can get rid of these extra turd monkeys. I don't know why I call them, but yeah, they're dead chunks. Like it'll remove this part of the key. Like it'll remove. Okay, so the way this new function, this is in 1.18. Now, entities were normally stored inside the chunk under this key. Now they've been moved to here. So in anything prior, you go to this key. You know what I mean? Hexadecimal. This is ASCII, and again, this is decimal. Decimal, hexadecimal, ASCII. The difference is just in the formatting. This Digby key stores your key as a pretty much an 8-byte. I mean, it's two long integers. I mean, it's one long integer, right? If I remember right, yes. It's 4 bytes in 4 bytes. Yeah, so it's literally, is it really 2 longs? I thought it was, no, it really is, because I don't remember being freaking 16 bytes long. I know it's not 16 bytes long, because I would have definitely noticed the difference in size. So it's half the key is, I mean, the whole thing is basically a 8-byte key for every storage key. And I mean, if you want me to get into the details, because I know it and might as well mention it so I don't forget it. This chunk key is calculated from the world start count from the DAT file in Bedrock. I mean, this is all about Bedrock. Yeah, I obviously should have known that, but this is calculated minus the world start count. Like the max value of a 64-bit integer minus how many times you start the game is the value of the storage key's first key. And then the second key is the count of entities that were created during that session until you close the game, save it, and reload it. Then all other entities created in that session have a different value, and the first value is the value of the first thing. Now it's encoded in a string format. I mean, inside the entities themselves, which causes a ton of issues. And then not only that, when an entity dies, it only gets removed from this dig pointer, which I call it the dig pointer because it's the digging pointer that goes to the actor prefix. And I'm looking at it, thinking about it as a programmer that renamed these things. But what they failed to do is simply add like a startup counter or a world counter to double check our actor prefixes existing in, just basically when they start the world, just double check the dig pointers in the world so that they match up to the actor prefixes to clean the world every so many starts. Like every fifth world start, it erases them or goes back so many. I think they should have done it that way, so it doesn't like sometimes like all the time your world just has to do this freaking like cleaning mechanism. But either way, and I think it's kind of neat because I wrote a part of this that can resurrect your entities. I mean, yeah, it's in the plugin I wrote, so you can resurrect dead entities after this point. I mean, I utilized it. Why not? It's a bug though, and it can become a huge problem for servers and stuff like that. So the actor prefix just literally is the key that's generated from the world start and the count of the entities, same as the unique ID of the entity, which is the reverse opposite, and it's forgot to mention it. That's in Little Indian encoding, and this is in Big Indian encoding. Anyway, so if you wanted to know, and now you know. Pending ticks, and if you didn't want to know, now you freaking regret you know. Okay, block extra data. This I have not used since here, so I'm not too much aware of it. I haven't messed around with it. Biome state, I have never messed with it, and I don't know exactly what it does. It doesn't even have any information on the site. Finalized state, that is useful if you don't want to. I mean, I've never really encountered a problem or a use for it, but it just tells you whether the chunk's in a state of like if it's been pre-generation or if it's been finalized. But normally you won't. You do might want to check this if you're working with raw because you're gonna end up with bugs and you're end up with some errors if you don't make sure that the finalized state is 2. And I'm pretty sure there's only 3 values: 0, 1, and 2. 0, and I can't remember if it's 0 or 1. I think 2 is good and 0 is like, what the heck is this chunk even doing here for? 1 is like, oh, should we even look at this? If I remember right, but yeah, look into that a little further. That I'm not 100% for sure about because I haven't messed with it that much. But the question mark is back again, and I've found myself deleting it when I was trying to get chunks to regenerate, and I'm working on a plugin, and I've got it working. I'm just cleaning it up so that you can force 119 in no time to just regenerate. Like you can change your seed and have it blend all the stuff together, which is I think a very useful thing. So stay tuned and I'll explain that and you'll find more about that. Code spawn areas. Those I haven't messed with, but this is pretty much embedded into the game, and I don't even know if you want to mess with that. But it'd be cool to find out what you guys can leave me in the comments. What can you do with that? I'd like to know. I don't mess with the education feature, never done it, but that's where that's located. Checksums, this is still there, and it was there. I mean, actually, I take that back. Oh, back up. No, it was there in 1.17, and when I put it back there, it seemed to help with the generation. So I'm still in a debugging process, and sometimes that can become a problem. You know, when you're debugging and running things, and you do a couple changes at a time, and I gotta go back and do individually double check to make sure. But I think causing adding that key, a blink with no checksum, helped helped with something, adding it to 1.19. So that might be required for triggering a noticeable difference into trying to go back into another version. I mean, I might not actually need a value, and I don't know how to calculate the XX hash checksums for the chunk. So, and I got to ask a friend that might be able to find out or look at some code, but I don't think that's required going back a version if they're empty. Now, if they're not empty, you might cause a problem. I don't know. Just a little bit of questions, and if there's any developers in here that can answer, obviously the chunk version's right here, and this definitely needs to be changed to cause some type of update in the blending. And this is the old one, though. This is the old one, and yeah, I don't even think you could upgrade from that version to 1.19. But it could be wrong. But that might be a use for it, but that's at least where you find the chunk version in 1.16. So let's go here. So these are the other keys that nobody mentions. This is where like your local player is in the database. That's the binary. You have to convert these characters into binary. Don't forget that. It's not text. It's ASCII to binary. So it's got to be converted in binary before you can access the database. If you're doing it from C, you got to understand that you're converting it to binary before you're calling these functions. It will not work in string form. Portals, that's another one. There could be several I'm missing, but most of them I'm not even aware of. But there's UUIDs and there's server something, and there's a way I distinctly chose between the server actuals, like because they'll throw server keys and all sorts of stuff in there, and you get really confused. And so yeah, that can get confusing. But it's under server is where your server players are. It has like 3 or 4 keys. I think 3 keys for each player. And they map out to each other. But if you want to edit their location, there's only 1 key. And you can look at my plugin, and I've mapped it out. I can't remember. I couldn't find it when I was making this. But this is a new key that absolutely needs to be removed if you're trying to force blending. And this is where it keeps track of all your updates and stuff. And so if you try to think you got everything right, try to get everything done, you forget they just added this one, and that would prevent updating. And I'm not totally sure if it happened in 1.18 or sometime in 1.19, because I just now noticed that key. And now we got the actor key pricks. This is and I explain it more in detail down here, which I've already explained it by heart up there. So I pretty much explained everything here, you guys. I mean, I got it, and it's like it's just a little bit more notes I got that I put in here, and hopefully it helps you out. So it's a 32-bit integer. It's 8 bytes, like I told you. And I wrote it down so I didn't forget it, got it right and correct. That's the hardest thing about making this video is I don't want to give you the wrong information, because I've been given the wrong information so many damn freaking times, and it leads to an endless freaking annoying battle of code and why doesn't it work? And so it does actually cause a problem with UTF encoding, even with the program that I use, which is Amulet, that a lot like. So that's what it looks like. 8 byte. It's not a string, and I don't know why they chose. Developers, for the love of God, let me know why. Isn't it a freaking a byte array? Can you fix that? It's a bug. I mean, it's screwing up everybody's encoding software. You guys just did it on purpose, I think. It's like we can handle it, but they can't. Ha ha ha. So, anyways, I'm annoyed. I'm annoyed by that, but I'm annoyed by how easy it is, but how complicated this whole entire thing really is. I'm sorry this video took long, and I'm really don't even want to rewatch it, because then I probably won't even upload it. So I'm hoping you guys got something out of this. If you didn't, I apologize. Thank you for watching. If you made it this far, I mean, and you learned something. If you have any questions, man, stay tuned, because I plan on making a tutorial for Amulet. I plan on making a tutorial for all my plugins, and it'll probably be less time than it takes to explain this complicated mess here. I mean, it is so simple though, but it is like there's a lot of information we just don't know, and so that's where it gets a little irritating. But yeah, a lot of the stuff we do know is actually really simple, like the compaction of the things, the headers. These are easy. That's easy. All this stuff. But stay tuned for more. I'll talk to you and see you guys in the next one. You guys all stay safe and take care.